Imagine standing on the deck of a massive aircraft carrier in the middle of the ocean. The runway is only a few hundred feet long, yet within seconds, a fully loaded fighter jet weighing more than 30 tons is launched into the sky at incredible speed. It may look almost impossible, but this is made possible by one of the most powerful engineering systems ever built, the steam catapult. Before every launch, the flight deck comes alive with coordinated activity. Sailors in different colored jerseys each have a specific responsibility. Some inspect the aircraft, others monitor safety, while the catapult crew prepares the launch system. Every movement is carefully choreographed because there is no room for mistakes on one of the world's most dangerous workplaces. The pilot slowly taxis the aircraft toward the catapult track. As the jet reaches the launch position, the nose landing gear is connected to the catapult shuttle using a launch bar. Another critical component, known as the holdback bar, keeps the aircraft securely in place while engine power is increased to maximum thrust. With the brakes released, the fighter's engines roar at full power. Even with all that thrust, the aircraft remains locked in position. The entire jet vibrates as the pilot performs one last instrument check. At this moment, thousands of pounds of thrust are pushing against the holdback mechanism, waiting for the launch signal. Beneath the flight deck, the real power is building. High-pressure steam generated by the ship's propulsion system is routed into massive cylinders running the length of the catapult. Inside these cylinders are powerful pistons connected to the shuttle on the deck above. When the catapult officer, often called the shooter, gives the final signal, the launch sequence begins instantly. In less than 2 seconds, the steam drives the pistons forward with tremendous force. The shuttle races down the track, pulling the fighter jet from 0 to approximately 150 miles per hour, or around 240 kilometers per hour. The acceleration is so intense that pilots experience forces of up to 4 times the force of gravity. The aircraft leaves the flight deck and immediately begins climbing over the open ocean. Without the steam catapult, a heavily loaded fighter carrying full fuel and weapons simply would not have enough runway to become airborne from a carrier. The steam catapult has served as the backbone of U.S. Navy carrier aviation for decades. It has launched countless aircraft, including the FA-18 Super Hornet, EA-18G Growler, E-2D Hawkeye airborne early warning aircraft, and the C-2 Greyhound cargo aircraft. Every successful mission begins with this remarkable launch system. Operating a steam catapult is far more complex than simply releasing pressure. Engineers must carefully calculate the aircraft's total weight, fuel load, weapons, weather conditions, wind over the deck, and required launch speed. The amount of steam pressure is precisely adjusted for each aircraft to ensure a safe and effective takeoff. Safety is always the highest priority. Every launch is monitored by experienced personnel who communicate continuously through hand signals and radio. If any abnormal condition is detected, even at the last second, the launch can be immediately aborted. Working on the flight deck is one of the most demanding jobs in the military. Jet engines produce deafening noise, scorching exhaust, and hurricane-force winds. Crew members wear specialized protective equipment while remaining constantly aware of moving aircraft, spinning propellers, and high-pressure launch systems. Although steam catapults have proven incredibly reliable, naval aviation continues to evolve. The newest Gerald R. Ford-class aircraft carriers use the electromagnetic aircraft launch system, or EMALS. Instead of steam, EMALS uses powerful electromagnetic technology to accelerate aircraft more smoothly and efficiently. This advanced system reduces mechanical stress on both the aircraft and the launch equipment while supporting a wider variety of aircraft, including future unmanned systems. Even so, steam catapults remain one of the greatest engineering achievements in naval history. For generations, they have launched thousands of aircraft into combat, reconnaissance, humanitarian missions, and training operations across the world's oceans. The next time you watch a fighter jet explode off the deck of an aircraft carrier, remember that behind those 2 breathtaking seconds lies decades of engineering innovation, highly trained sailors, and extraordinary teamwork. It is a perfect example of technology and human skill working together to accomplish what once seemed impossible.